Hey everyone, Mrs. Spatola here. Here are the answers from last night's homework, where you had to make T-charts and list all of the factors of the given numbers. So pause the video, take a look, check your work, and then we'll slide down and look at the remainder. And here are the remaining answers for the rest of the page. Hope you did a good job. Don't forget, you can use your calculator and you can use a multiplication table to help you to do a better job. All right, let's take a look at today's lesson. Unit 4, Lesson 2, Prime Factorization. How do you write the prime factorization of a number? Before we get started with that, let's take a quick look at our do now. Remember, the do now questions are often found on your unit test. So number 1 says list all of the factors of 54. So if we were to list all of the factors of 54, I'm thinking I am going to make a T-chart for 54. So it would be 54, and I make a T-chart, and then I list all of the factors. So I know it's 1 times 54, 2 times 27. I know 3 can go in because 5 plus 4 is 9. So 3 times 18. Can 4 go in? Nope. 5? Nope. But 6 can. 6 times 9, and I am done. Okay. And it says list all of them. So if we write them in the chart, I can list them 1, 2, 3, 6, 9, 18, 27, 54. Number 2 is a review question. An after school program has 15 out of 50 students participating. Write this as a fraction and decimal. Remember, you always want to start with the question. So, what is the question asking us? Well, it's actually telling us to write 15 out of 50 as a fraction and a decimal. So, first thing as a fraction, I know the first thing I'm going to need is a fraction bar. And it's 15 out of 50. So, it's 15 out of 50. That's how we would write it as a fraction. Now we want to write it as a decimal. So what does that mean? When I want to change a fraction to a decimal, it means the top number divided by the bottom, or 15 divided by 50. And if we were going to rewrite that, it would look like this: 15 divided by 50. Now remember, you can always put this in your calculator. That's a definite okay. If you were to continue like this, longhand, we would put the decimal because 50 cannot go into 15. It goes in 0. I bring up my decimal. I annex a 0. Can 50 go into 150? Yes, it can. 3 times. So 3 times 50 is 150, and I would be done. So as a fraction, it would be 15 over 50, and then as a decimal, it would be 0 and 3/10. If we take a look over on the right, we see that there is a chart here for prime factorization. This is what we're going to be doing today. We're actually going to be making what they call factor trees, a factor tree. And basically what you do with prime factorization is you are breaking down a composite number until all of its factors are prime numbers. Now, this is different than the T-charts that we did yesterday, because in the T-charts we listed all of the factors. But in prime factorization, what they're looking for us to do is break down all of the composites so that all we're left with are these prime factors of each number. So, for example, we take the number 72. And what you do is you take two numbers that multiply out to whatever the given number is. In this case, it's 8 times 9. So they're multiplying 8 times 9. Now notice there are two separate things going on here. So for the first one, we're looking at just the number 8. And now we've broken it down into 2 times 4. Now it's 2 times 4. Now notice 2 is a prime number. So what we would do is circle the prime number and then we keep going. 4 is a composite number. So we would break that down until we're left with 2 prime numbers, which would be 2 times 2. Now, once you have all of the numbers circled, you're done with that side and we can go on to the other side, to the next number, which in this case is the 9. And with the 9, we're going to break that down into 3 times 3. And 3 times 3 is 9. Those are prime numbers. So now all I'm left with now is prime numbers, are prime numbers. So if I look and notice how they have it listed here, they did such a beautiful job here. So watch, you list all of the numbers from least to greatest. So it would be 2 times 2 times 2 times 3 times 3. Now notice how they wrote it here. They wrote 2 times 2 times 2 times 3 times 3. If you put that in your calculator, it will multiply out to a total of 72. But now notice right below that, they put it in what we call exponential form or exponent form. So 72 is equal to 2 to the third power, which is your 2 times 2 times 2, times 3 to the second power. And if you look at it, 2 to the third is what? 8 times 3 to the second, which is 9. And 8 times 9 is 72. That's what we're going to be looking at and doing in today's lesson. So let's have a look. There are different ways to represent the factors of a number. One way is called a factor tree. The other way we saw was a T-chart, and we did that yesterday. Today we're going to focus on the prime factorization using a factor tree. So step 1 says the following. You're going to choose any factor pair to start what we call the tree. Number 2 says if a number is in the pair, if a number in the pair is prime, circle it. 3, if a number in the pair is composite, continue and write it as the product of 2 factors. Step 4, continue adding branches until all factors are prime. And then lastly, write in exponential form with an exponent from least to greatest. So that's important. From least to, we want to include that least to greatest. Okay, it just keeps everything organized and you'll get it right every time if you keep it all organized. So let's take a look at the first one here. Well, actually, let's look at the example first. Here's the example, 18. Now notice, they picked 2 random numbers. They picked 3 times 6. You could also pick 2 times 9, and that's going to get you the same prime numbers in the end. You will have the same exact answer. But notice, 3 times 6 was chosen. 3 is a prime number, so the 3 is circled. We circle the 3, okay? Times 6. 6 is left. Now we're breaking that down into a product of prime numbers. 2 times 3. They are both prime, so now all of my numbers are all circled, so I'm left with 2 times 3 times 3, which is equal to 18. And then my final answer, there's only 1, 2. You put them in order from least to greatest. 2 times 3 to the second power. And that's how it goes. Let's look at number 1, which says find the prime factorization using a factor tree, not a T-chart. We did that yesterday. Now let's look at the factor tree. So in this case here for 52, we're going to pick any 2 numbers that multiply out to 52. You definitely don't want to pick 1 in itself. I should say pick any 2 factors besides 1 and itself, because then you're going to be in an endless cycle. So here it's an even number, so I know that 2 can go into that number. So I'm going to pick 2 times, and now 2 times what is 52? 2 times 26. If anybody plays cards and you know if you split a deck of cards is 52. If you split it in half, you have 26. All right, so I'm left with 2 times 26. 2 is a prime number, circle it. Is 26 a prime number? No, it's not. We can break that number down. It's an even number. I know that 2 can go into it again. 2 times. Now notice I'm using the X. Could I use the dot? Absolutely. Either one is fine. 2 times 13. 2 is prime. 13 is prime. Now, in order to check it, I can just multiply in my calculator 2 times 13, and I do get 52. Now I'm going to put it in order. 2 times 13 equals 52. And finally, in exponent form, 2 to the second times 13 and is equal to 52. Okay, you can just leave it as 2 to the second times 13. You don't even have to put the equals 52. You can if you want. And that's how it goes. Let's look at number 2. Okay, number 2, 64. I like to go split it in half. I say 2 times 32. 2 is a prime number. 32, I can split that in half. I know it's 2 times 16. I could split that in half. Could I do 8 times 4? Of course I could. There's a couple of ways you could go about it. Here, I'm going to select 4 times 4. Those are not prime numbers, so I'm going to keep going. This is 2 times 2. Circle, circle because it's prime. Times, don't forget the other 4. 2 times 2. And there I have it. So 64 is equivalent to 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, which is equal to 2 to the 6th power. If you want, you can check it. I would strongly suggest put in 2 to the 6th power into your calculator and you should get 64. And that's how it works. Let's look at number 3. Number 3 is 32. So in this case here, I'm going to this time do 8 times 4. And it doesn't matter what you start with, you will always have, if you do it correctly, your prime factorization will always work out to be the same. So now 8 is 4 times 2. I'm going to break down the 4 here into 2 times 2. All I'm doing is breaking up my composite numbers until all I have left are prime numbers. So here I am, 1, 2, 3, 4, 5. So it's 2 times 2 times 2 times 2 times 2, or 2 to the 5th power, and I am done. You can definitely, and I would strongly suggest you check it in your calculator. Okay, let's try number 4. For number 4, I'm going to start off with 4 times 12. So now what I'm going to ask you to do is pause the video and try this one on your own. And for 48, it turns out to be 2 to the 4th power times 3. Again, you should be using your calculator. And let's check number 5. Number 5 is 81. We're going to try, let's pick 9 times 9. Give it a pause and try to do the prime factorization. Pause the video now. And with that, you can see it's 3 times 3 times 3 times 3, which is equal to 3 to the 4th power. Hope you did well with that one. Let's go on and take a look at the next page, which is going to be your homework. So on the next page here, we have 6, 7, and 8. You're going to find the prime factorization for each of these using a factor tree. Number 9 and number 10 also, some more practice. Number 11 is a word problem, a little trickier. In a game, you draw a card with 3 consecutive numbers on it. Now remember, the word consecutive means one after the other. One after the other. Okay? So you can choose one of the numbers and find the sum of its prime factors. Then you can move that many spaces. You draw a card with the numbers 25, 26, and 27. Which number should you choose if you want to move as many spaces as possible? Okay, so let's go back again. In a game, you draw a card with three consecutive numbers. So there you go, 25, 26, and 27. You can choose one of the numbers and find the sum of its prime factors. Then you can move that many spaces. So basically, what are they asking? Which number should you choose if you want to move as many places as possible? So I will give you a clue: 25, 26, and 27. Okay, this is a challenge word problem. You should definitely be able to do it. You're looking to find the prime factors and find the sum. Remember, the sum, what is the sum? The sum is an answer to an addition problem. So try the rest from there. And then number 12 and 13, you should be pretty good to go. So give it a try. On this last page, this is a bonus activity. Perfect numbers. In math, a perfect number is a number that is equal to the sum of all of its factors, excluding the number itself. So, for example, the number 6 is a perfect number. The factors of 6 are 1, 2, 3, and 6. The sum of the factors, then, excluding 6, is 1, 2, and 3. 1 plus 2 plus 3 is equal to 6. Therefore, it is called a perfect number. Again, this is a bonus challenge. Number 14 says, find the next perfect number and show why it's perfect. That's a little tricky. And then lastly, here's a challenge. Is the number 128 a perfect number? And is the number 496 a perfect number? I'll give you a clue. For those two, you have to find the factors and see if the sum of the factors, excluding the number itself, add up to the actual number. Good luck. I hope you give yourself a challenge and give it a try. Have a great day, and remember, be kind.